Okay, recording started. I'll start again. Okay. So whatever we have seen in the last session is we have seen packing, unpacking, and how this unpacking is useful when it comes to access through the dictionary. Okay. So here this is like the simple assignment wherein we are just giving single value to this. Okay. This is called as multiple assignment. A is equal to B and this is equal to 5. Multiple assignment. But what we do is A is equal to B is equal to 5 is equal to A equal to 5 and B is equal to 5. So this is the other way of as a initializing variables with multiple assignment. And here there is a way we can do packing. So packing is something like if A is equal to B is equal to 2 comma 3. Were you guys able to see my screen? Others, could you please confirm? Is my screen shared? Can you confirm the chat? Yeah. Edwin, I guess they're able to see your screen. Could you please check your session if you are not able to see?
Now I am able to say.
Okay, okay. So as I was saying, this is a simple assignment and this is multiple assignment and this is called packing. So what we are doing here is a comma, I mean, so what is going to assign is a is equal to 2 comma 3. It's actually it is assigning as the tuple. You see this 2 comma 3 is taken as an individual value. One second, before getting to this, I will give you one more detail. So a comma b is equal to 2 comma 3. In this case, what is going to do? It will assign A is equal to 2 and B equals 3. Okay, this is how it assigns. So this is the expected behavior when you define like this. Okay, but when it comes, if you are trying to assign these values 2 comma 3 for A and B, so what happens here is this 2 3 will be packed as a single unit, which is called as packing, which we call here as a tuple. In general, it takes as a tuple. Okay. This tuple will get assigned to A as well as B. So now the results will be like A and B will have this 2 comma 3. This is called as packing. And when you go for unpacking, what happens is, for example, A comma B equal to 2 comma 3. This feature is called as unpacking. So here what it does is it will assign, a minute, I just made something wrong here, I guess. Yeah. Suppose you are trying to give this. You are trying to assign a value, tuple values to these variables. So here this is packed as a single unit. Okay. This packing of it's nothing but an array kind. Okay. This particular array of values we are trying to assign to the each individual values. Internally Python what it does it unpacks this and it will get assigned the values a is equal to 2 and b is equal to 3. Okay. That's all we saw. And coming to dictionary. So dictionary is, as you know, it's a key value pair. So in the key value pair, when you're trying to access the values, there are multiple ways. If you do dot items, it will return you. I think you can go through the recordings for the further details. This is the basic foundation of this. Okay, to understand what is packing and unpacking. If others join, I will move to the next session. Okay, so we have time. Okay, so now I will show you what is this dictionary. Dictionary is something like I've showed you on the top. Just give me a minute. I will shortly explain what is it. Okay. Dictionary is something like this. Before others join and try to quickly brush through this. So dictionary is the way how we define if this is a key value pair. If you say df1, it will give me 1. Okay, which is stored inside. So here one is the key, one is key, and this one is the value. Okay. So whenever you wanted to access a value, you used to give the key, pass the key. Suppose you are using 4 here, we have to use 4 as here the 4 is the key and value 4 is the thing value. So this also can be accessed. When you wanted to loop through this, so what we do, d dot items if you do, it will give you the value elements in the tuple format. That is what we have seen here. Just give me a minute. Yeah. So if you see the value of items, then we whatever value individual value are getting as a tuple format. So this particular values, when you wanted to loop through, so we write a for loop like this, k comma v in d dot items, and k will be getting this value 1 comma 1. 1 will be assigned to k, and the string 1 will be one will be assigned to value v. Why it is assigned? That is why we explained this unpacking. Okay. This is pack of single unit which is unpacked and gets assigned to k comma v. That's what it is. Okay. You go through the video, you'll understand. And now we are getting this for else, and for else is something like a new logic in Python. I'm not sure, it might be existing in other language. I believe when I encountered this particular concept, I only seen this in Python. Okay. So generally what we do here, the logic is we have a array, and we are trying to find an element in this array, and that element is found or not. What is the condition we do? We have a flag check. Okay, using a flag, we are going to check whether the element is found. If it is found, we are setting it true. Otherwise, this value will remain false. Once the loop is done, we'll check the value is found or not. So by using this Boolean variable, if it is false, then this will become true. So element is not found, it will print. Otherwise, whenever it is found, it is going to break this condition, and this condition will never get executed. So in this way, we can find an element is present or not using this logic. Okay. But in case of Python, this particular found and all these flags can be replaced with a simple else condition. Okay. So when this else will get executed, once the complete list is consumed, for example, here the list is 0 to 18, and the value 13 is present in between. We are trying to insert it if for our testing purpose. If it is not there, this will go through the complete list. If it is not able to find after traversing everything, if it completes, it comes to the end of the list, by default it will go enter into the else part. Okay. If it consumes the complete list, then it will go to the else part. If else, I mean, if suppose it is not able to reach to the end of the list, it's due to some conditional break, it is going out of the loop. In those occasions, what we do, it will break and this else part will not execute. So we are trying to leverage this particular concept to solve our logic. Here, whenever 13 is found, we are just breaking the loop and saying element 13 is found. If it is not found after after consuming the complete list, it is going to give you not found. Okay, that's the idea. So this here we explained what is Boolean, and again that's it. Okay, this is where we are now. So let's move on from here. Okay, just give me a minute. I'll just have to ask.
Eddie, we are not able to hear you.
Oh, I'm extremely sorry. Oh, sorry. Sorry, I just made it on mute. Yeah. So now what we are going to look into is like the concepts of Python. I mean, functions in Python. So in Python functions, right? I guess we have had a brief hands-on on Python functions, but we didn't have the theory session. I just wanted to explain it again to give a clear picture of it. Okay. So Python function is used whenever any programming language. Why function constant is come to a picture is you can write all these logics in a one lengthy way. Okay, the readability of the code will become very messy, and there are parts where we will be using very often. Okay, some set of codes we'll be using very often. A repetitive code will be finding. This repetition of codes can be replaced with function. That is the need for functions in any programming language. It's not only in Python. So Python, how the function declaration syntax follows is we are using this keyword called def and give the function name, and what are the arguments it's going to take, we are going to feed it, and the end results of this we will be computing and return that. Okay, suppose we wanted in a example, some application where you wanted to compute tax or something like that. So where you will be calling the tax computation every often. Okay. Every once in a while we'll be calling. So instead of writing the same logic again and again, we define that as a function. Whenever we need compute tax is the function we can call and return it. Okay. So that way we can know. I mean, that is the way we can write a clean coding, as well as it gives a good readability. The code maintenance also will be very good. So in future, if suppose you are only looking at the same code, if it is a few lines of code, you will be able to follow up. If it is 1,000 or 10,000 lakhs of lines, writing as a continuous set of instructions, it is impossible to read. So that is when functions are come in handy. So here the logic of function is okay. So we are taking this function name and arguments. Okay, and let me explain you with a simple example. Suppose we wanted to use this add function. I wanted to execute. Okay, 5 comma 4 like this. If we do, it will automatically calculate. For example, 5.8 plus comma 2.8. Okay, just print the output of this. What is the value is going to return? That value you can directly capture inside a function. Okay, print function. Okay. So here you see you are not calculating this 5 comma 4 every time. Okay. So this is a simple process. Suppose you wanted to calculate after summing, you wanted to do some kind of discount in that. Okay. For example, instead of this, just make the function as discount. Okay. Suppose you are going for a shop, you are buying some two products. Assume it is a two product, and they are providing a flat discount of 10% of discount. Okay. 10% discount they are providing on the product which you are buying. So what you do? So you will be adding the total value, the total amount, whatever we are receiving. So that particular, so I'll just define a given better name instead of arg1, item 1 and item 2. Okay, item 2. Okay, two items we are buying, assume it. Item 1 and item 2. Okay, so in this case, the discounted price I should be able to send it. Okay, so how you calculate the discount? So how much is the discount after 100%, I mean 10% of this, right? Discounted rate. There will be total minus. So what is the discount we have provided? 10% of the amount, right? Which is nothing but zero point 0.1, which is like 1 by 10, right? Yeah, zero point 0.1. Okay, let's make it 10% of this value, the total amount. That is the discount we are going to give. Okay, say for example, we bought a product for 50 rupees. Okay, and another both of the product was 50 rupees, total 100. So what is the end discounted product we'll get? Okay, let's see. Discount. After discount, what is the price? Uh, okay, let's execute this. There's a problem here because we are not returning the value. Okay, return the discounted value. Okay, now we can see 90 rupees. So Suppose you are running an offer in for some occasion, so you wanted to do something. So instead of embedding this logic inside, so we can write a function of this. So for discounting, so we can come up with this kind of. So this is one such an example. So in the real case scenarios, there are lots of examples where such codes can be, where repetitive codes can be written as a function. So you need it's a programmer's responsibility to identify this particular set of code can be written as function or not. Okay. So this is the simple logic of writing a function. So what we have done is we have taken the value 50 and 50. So here 50 is for item 1, it is 52. Item 2 is get assigned. And the total value will become 100. And out of that 100, we are going to have a 10% discount. Out of the 100, 10% discount is 10 rupees. That 10 rupees is calculated by this. So we are minusing that discount, and then final discounted price we have calculated. That value we are returning. Okay. This is what the function, this is how the function works. Okay. Mhm. Okay, this is a general function. So there is one more concept called, in particularly in Python, we have, I mean, there are other languages also it supports. Let me introduce this function which is called as anonymous function. Okay. We call it as anonymous function, which is nothing but, also they call it as lambda function. Okay. So whenever you wanted to define a function, you have to have this particular structure and you have to give the names of this function. Okay. But lambda function is something like we don't need to define in this format. Okay. So we don't need to have a function name. So it's just like a kind of an expression which can be assigned to a any variable, and that variable becomes a function kind. Okay. For example, I have a requirement. Uh, okay. Um, Give me a minute. So let me explain you the syntax before getting there. So lambda, the syntax is, say for example, we are taking how many arguments. So we start with the keyword lambda and we'll give how many arguments we are going to take, one or two, and what is the result you wanted to print. If suppose there is a one-liner function, so we can go with, instead of defining this way, the above way, we can go with a normal lambda function itself. Suppose here we wanted to calculate square sums, for example, x. Okay, we know this is kind of exponential operator where you give x squared. Okay, then y squared. Okay, so this particular value we are going to store it. Okay, so lambda is a simple function expression kind. So where you have a single line function, instead of writing a normal function, we can define an anonymous function. So this lambda, what it will do, just give me an example. Suppose I'm just giving my square. Okay, function called my square. I'm just giving this, and I'm just going to assign this. What I'm going to do, I'm just going to define a lambda function. Lambda is a keyword here, and what are the arguments you are going to take? You define here, x comma y, and what is the operation you are going to give here? That we are going to do x squared plus y squared. Okay. Now, whenever you wanted to call this my square, it's like a simple function call. Suppose I'm passing 2 comma 2. The expected result is 2 squared plus 2 squared, which is 4 plus 4, 8. Okay. Expectation. Let's see whether this aggregates or not. Okay. So you can see the values are getting added. So to validate this, whether we can replace with 3. So what happens is 3 squared, which is nothing but 9, and 2 squared 4. 4 plus 9, it should give 13, right? So when there is a need for a lambda function, how the programmer can identify is when the functions are very small and we are not, I mean, sometimes there are situations in Python alone, some of the arguments itself, before entering inside the code only, we can define one of the argument as lambda itself. Okay. In such case, it will be helpful. I mean, the main idea is whenever there is a simple single line functions, we can replace with a lambda functions. This is one of the alternative given by the Python. Okay. And sometimes we can embed this lambda function inside the function, normal function definition itself. Okay. That also we'll see. I don't know whether, okay. We'll see that. So this is one such a way. Okay. So how you define lambda function, if you have any questions or confusions, please let me know. I will explain it again. So before asking lambda function, to define a lambda function, lambda keyword we have to use. Then we have to pass the arguments. Then a colon followed by the argument expression. Okay. This is the syntax. Okay. And this particular lambda expression we are going to assign to a name. So it's like a variable name. Here this variable name become a function. Okay. So this particular part which you are calling without having any def keyword, without having any name of the function, without defining any name of the function, we call this particular expression as a, I mean, anonymous function, because anonymous is the keyword, I mean, English word which says it is like unknown, it is not exist, something like that. So in that case, this definition perfectly fits, because this particular, we are not giving a function name to this until unless we assign to the variable this one. Once we assign this, we can call this. Without assigning also, we should be able to call. We can embed inside the expression, inside a, what do you call, inside a function itself. Let's see that also. So before that, I just wanted you to try once to write a lambda function. Okay. I wanted you to take three variables and write your logic. Okay. Write your logic of adding the first two variables, and the last variable value should have be, I mean, it's like a plus b minus c. Okay. This is my end result. It should be how you write this lambda function. Okay. Can you write it and put it in the comment? We'll see. My expected function is, I'll be passing three variables a, b, c, and the end result should be giving a plus b minus c. Okay. Can you write a lambda function and copy and paste it in the chat session? Yeah. So if you're not able to understand lambda, please ping me in the chat. I will explain it again. Otherwise, you guys try to write this function and copy it in the chat. Okay? Please make this interactive so that I will know whether you guys understood or not. These are kind of important topics which we use in Python very often. It is must to understand. Okay, even though it is basics or something, what we are trying to cover here. But I wanted you to touch these kind of topics. Try writing. You understood, right? What is my expectation is, what I'm asking you to do is, this is the expression. Okay, I want three variables, and for example, if I getting value a for 3 and b, we'll just add it, then we'll just minus with the c value. Okay, this is the expression, and the expression I want, and I want a result from this. Whenever I call this function, I should be able to calculate this. You write your logic and paste it in the chat session, we'll do it. You can take this as a reference. Someone start writing. Actually, you don't need to execute and check. You can directly write in the chat session. I'll copy and execute for you. Okay. Yes. Okay. Okay. Let me take this one. So whatever like I shared, I will try to execute this. Just test. Yes. I'll just say test function. Test function. So now what I'm going to do, I'm just going to call this test function with the values whatever I have. So here 3 plus 5 and 8, which is equivalent to 2, right? 8 minus 6. Let's check this function works on. not 3 comma 5 comma 6. Okay, the expected value to we are getting. Okay. So this is how we write lambda functions. Uh, you guys understood? Others, I guess you didn't try it any. Oh. Sorry, Mahesh, is my voice still not audible for you? Others are able to listen, right? I hope so. Hello, hello. Am I audible to you guys?
Hello, sir.
Yeah, we can hear you.
Yeah, yeah, fine, fine. Thank you. So that's it about Lambda functions. I just wanted to give a brief introduction about it. And you know how the Python function works. And uh, Loki, can you give me an example of using this Lambda function inside this function as an argument? Can we? I'm not getting proper example of it. Give me a minute, let me check. Because that will be complicate the things. Then I'll drop that.
I will create a function and I will share it. You
Yeah,
just
yeah, fine.
continue. Yeah.
Yeah, yeah. Uh, So for today, whatever we have seen is like packing, unpacking. We have seen, and we have seen for else, and I asked you to work on while else, and as well we saw lambda functions. Uh, okay, one more topic I just wanted to cover. Okay, let's go with iterators. Okay, so lambda functions we'll try to revisit if we get other examples. Before that, I just wanted to go with iterators. What is iterator? Okay. So when I say Python internally, what it does? So when I say whenever I'm defining a list, okay, to traverse through this list, what I do for val in a print val. This is what we do. It's a simple looping function. We just give this value a and it will print each of these values. And I explained you with a flowchart where I said for loop, what it does, whatever iterables we pass, it will iterate through each of these elements. It will try to print. So internally, what happens inside this? That's what we are going to see. When you are saying an iterables, so what we do internally is, yeah, yes, there is a logic called as iterator. Okay, so it uses a keyword called iter, and there is an operation called next. Okay, these are the main keywords when it comes to uh, iterator. So what happens is, so internally, it will not evaluate this list as it is. So Python has its own way of handling it internally. Okay. So that particular logic, if you understand, if suppose you are coming up with your own class kind of things, and you wanted to loop through for loop, we can make use of that. Okay. That is something. If you go for the class concepts level, you will be able to understand that. I don't want to get to that level. So let me explain you a simple term how this iterator works. Okay, the same for loop we are going to access using how we are looping through these values, the same thing we are going to use using accessing the values using the iterator. Okay, let me tell you. So now a is the value which is having this particular list, right? Yeah, now I'm going to do assign this to a keyword called iter. Okay, iter. Okay, iter of a, I'm assigning this called as my iterator. Okay, my. Okay. So this particular thing, what it does, let's see what is this my type of it. This is called as list iterator. So what does internally is it takes this value of a, type is list, and we are creating a list iterator. So there is a built-in Python. This one is there, respective iterator. It gets assigned to this and it given to us. Okay. So using this, how we can access the values? Okay. For accessing these values, what you do, we use next. Okay. This particular my it, right? Just give me a minute, I can explain you with the diagram. Okay. Okay. So whatever we have here, I'm just defining a list. Okay. We have values 1, 2, 3, 4, 5, and 6. This is nothing but a list, Python list. Okay. So I'm going to access this list using an iterator. Okay. So what happens is Python offers you two keywords which is called as iter to access an iterable. Since it's an iterable, you can access using this. Okay. Then we are going to have one more keyword called as next. So what iter does is it will initialize this particular iterator and it will keep the point to this thing. Okay. So this is what iter function does. Okay. It will give you a pointer to the access to this list. Next, what it does is when you call next, by giving the passing this particular iter object, whatever we have initialized. For example, here our case is myit, which is generated for us. What it does is it will read this value and it will return this value. And at the same time, it will jump from here to here. Now the iterator will be pointing to this. Okay. I will explain you in this code. So now if you're saying the value of A is 9 to 10, right? I'll just redefine this statement again. And you will get to know. Okay. And I'm printing the value. Okay. And what I'm doing is I'm just giving an iterator assigned to this list and trying to access the values. Okay. Now in this particular set of lines, what I have done, I created this list. Okay. This is the list I created in the first line. I printed this and I created an iterator. Now the iterator is pointing to 0. Okay. As per this, I created one more thing which is called as 0. Okay. So now my iterator is pointing here to the 0th position. Okay. Now what I'm going to do, I wanted to access this value. How I will be able to access this value? Using the next operator. So now if I print next of my 8, what it will print? Okay. Better I will do this in the next cell instead of confusing. In order to avoid the confusion here, I will just create a new code cell. Here I will execute. Okay. Yeah. It gave me the value 0. Okay. Now the pointer has returned this value. I mean, I know it is not working. Yep. So now this value is returned. So since we called this next, the next iteration is moved now to the next statement. Okay. Now I don't need to change the code. If I execute it once again, what happens is we are getting 1. Okay. Every time the next is getting called, this constant, that iterator pointer, right? What we are talking about is the pointing, the current pointer, so which is pointing to 0. Now we are moving to the 1. Okay. Now if I do this again, if I execute this line again, it is moving to the next line. I mean, next location. So likewise, it keeps jumping. Okay. So how many times you execute, that many times it will change. This is what under the hood Python does this. Okay. So now it is 5 for the fifth time, sixth time, seventh time, eighth time, ninth time. Now we came to an end of the list. What happens? We're getting an error. Stop iteration. So beyond this, we cannot go through. Okay. Now it stopped. So once the iterate is moved, it is not possible to come back. So the direction of OVA, they provide only two functions. One is iter, it will give you one pointer to the iterable. Okay, it just gives the one pointer to this. Okay, it just gives one pointer to this iterable. Okay, so once it is done, and whenever you call next, it will be pointing to this next. Then the next time it will be going to this. So likewise, dynamically it will change from the current position. It never goes back in this direction. It only forwards. Okay, the next will be starting from this position, then we will be moving from here, then we will be moving from here. Likewise, it keeps moving. When it encounters the end of the iterable, it will give an error message. Okay, this is how internally what happens behind the for loop automatic iteration. What happens is, using this iterator operation only, it is able to go through each of these values. Okay, so this is the internal implementation of looping through these iterables inside Python works. Okay, and when you go for this implementation, there is a class con. I mean, we didn't go to the class concepts. Once we know the class level concepts and how we can override this iter for your custom way, that we can see once you get into the advanced topics. But I guess that is out of the scope of this particular class. I don't want to get to that. Okay. So I'm just going to stop this topic with this. I'm not going to get in depth on this. So if you guys are not able to follow, I can explain it again. The logic is very simple. We are having two keywords in Python. Whenever you give any iterable list or tuple or anything, so what it takes is, it takes how we are going to access this list is, we are going to use this iter function to get the pointer for that particular iterable. First step. For accessing the values, we are going for this is. So this is like to get a cursor or pointer, whatever we call. Okay. I'm referring, this is not, maybe may not be the proper way of saying it's a cursor or pointer, but for understanding purpose, I'm saying. Okay. And when I say next, it accesses the value. It accesses the value where the current iter pointer points to, and advance the advances or moves the pointer to the next immediate element. Next element. If it starts from 0, whenever you are accessing, if for example, assume this as a iter and next. Okay. Whenever next of 0 is called, I mean that iter with respect to that, and that's what I'm saying. So this iter will get the value will get written, and iter will be mounting the 1. Next you do next of this iter again. It will advance this particular iter to 2. So likewise it keeps going until the end of this list. Once it goes this, the next will go to the stop iteration. That is what we observed here. Stop iteration. So this is a kind of an error which needs to be handled by the programmer. Whenever you implement this, we need to take care of this. So when you should stop this iteration, this is an indication the iterator cannot go beyond. That's it. So this is something out of scope of this topic. I just still wanted to explain. That's why I explained. You should know what is happening under the hood of Python list. Okay. So when I say Python for loop, it automatically does. It is magically does, but you need a deeper understanding. Well, how it does is via this. Okay. That's why we walk through that. And with this, I will move on to the next topic. Yeah. So far you guys are able to follow up, right? Hello? Yeah. Are you guys able to follow this session, or else if it is too complicated, I will move the next session to next session to tomorrow, or else I can start. It's going to be very simple. The next topic which I'm going to discuss is about slicing. Okay. That is compared to these topics whatever discussed, it is a very simple concept which I can explain you very easily. Okay, let me try. If you guys feel don't want to go for it, I can stop. I guess most of us are ready. I'll just take that as an yes and then I'll move on. Okay. Okay. So now I'm going to give you a list. Okay. Is the list as you see, list range of, going to define a list of 100, for example 100 with step size of 2. Okay. So what are the elements? What are the values it created now? Okay. So 0 to 98. Okay, we have all the even numbers from 0 to 100 we have, excluding 100. Okay. This particular list, suppose this list can be very huge as well. Sometimes when you are dealing with this huge list, instead of accessing the complete list, we will be focusing only some range of values. Suppose you have a memory, not a memory, and just suppose you want to deal with 10 data at a time. You have a function written for that, something like that. Assume that way. So for feeding that particular function for 10 records, what we need to do, we might need to create multiple 10 slices of this particular list and then feed it, right? So slice in the sense, what I'm saying is here we are just keeping from 1 to 10. We'll have the first batch. Likewise, we will split and then we'll take. So that is the requirement here. But how that can be done without actually slicing, we can slice the existing list. That's the idea. Slicing is something like we have this list. Okay, just give me a minute, I will create one more. So slicing is something like we create a big list. Okay, we have a big list and we wanted to access range some or not complete range. Okay, some range of values. For example, 10 samples at a time. So we wanted to break this list into multiple slices. Slices means just general English term. Slicing the like a fruit or anything which you slice, it's making into multiple pieces. Okay. So here also we can do that. For example, this is the size of 0 to 1, 2, 3, 4, 5, 6. Okay. 60. And each slice list I wanted from 10 size. Okay. Individually. I want to do this way. So how we can access this particular range of values? Okay. There is a simple way Python provides to access this, which is called as slicing. I will tell you how to do that. Example. So this is the same logic how we used for the range function, list function, when you're defining, the same thing we are going to do. So there is a colon operator, okay? So this particular colon, when you use this, you have to define where to start and when to end, okay? So here what we are going to do is the starting index position, starting index, and here we are going to give the ending index, okay? This is the slicing operation syntax, okay? Here A is the list. I'm just going to pass this one. So now suppose I'm giving the values of, okay, from 0 to 10, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? This is the values, these are the values I wanted to access, okay? What I can do, I can give start from the 0th index and end from 0 to 10, okay? It gave me 18, okay? Yeah, okay? So literally speaking, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Till the index 9 it goes. It didn't take the value 10. It is similar to this. When you see range, right, it also does the same. So it starts from the starting 0 and it ends at the value before 100. Okay. It will not consider 100. That's the ending. So it will in the similar way, even the slicing also works. So here 0 to 10, instead of 10th place, it will stop at the ninth index itself. Okay. This is slicing. So here we made a slice of 10 by 10. So now we have to start the next slice. So how we can access that? Print. The next slice will be like this. A of. You don't need to give this much space and all, just for the readability. I'm just giving you. So we have to start from the 10th index and end before the 20th. Right. Okay. It excludes 40 and from 20 to 38 we go. Similarly, we can slice this 20 to 30, 30 to 40. This operation is called as slicing. Okay. So we have all the values covered. Right. So this comes in handy whenever we need to deal only with some set of operations. Those occasions, this slicing operation will be very helpful. And there are cases where we can do, so whenever you do list insert, right, what we do, let me recall that. Okay. Say for example, we have this list of range of 10, okay. We have 0 to 9. I want to insert some element at this particular index position. So it's something like fourth index. At the fourth index, I wanted to insert some value called 4 point or else 3.5. Okay. What you do? A dot insert the index position 4. And what is the value you're going to insert? Something like 3.5. I'm just going to insert. Okay. After that, I'm just trying to check the value of that. Okay. Now we got these values. Okay. What if suppose I want to replace this 3? Okay. Uh, Starting from index 3 to 7. Okay. I wanted to replace with some single value. So what I can do with this slicing, we can do that operation. Let me check. Okay. 3 to, for example, 7. Okay. What is the value? 3, 3.45. Okay. Value of A is different. print a. I'm trying to give these values. Okay, print of this particular slice. This slice comes from the index 3, 4, 5, and 6. Okay, that's what it says 3, 4, 5, 6, excluding 7. Okay, now I wanted to replace this particular set of values. Say, for example, I want to declare with something like 99. Now, what is the A? How the array changes? When the list changes. What happens here? Something you made a mistake. Confused here. Oh, okay. List assignment we can do. What happens with A is can only assign an iterable. Sorry. We cannot assign this way. Yeah. So there is a syntax it follows. So when you are trying to slice and insert a value, so that value also put should be in a iterable container. So here what we are saying, if you are having a single value which is like an integer value which cannot be inserted, so that's why I just replaced with this enclosed with a square bracket, which is nothing but a list. I'm trying to insert. Okay. So now what happens is from 3, 3.5, 4, 5, this particular set of values is getting replaced by 99. So this way we can change the value of particular range of values you wanted to remove and replace with something else. We can do that. Okay. So this particular slicing and slicing assignment is helpful to deal with multiple bigger range of values. Okay. That is what I'm trying to explain here. You can explore there are multiple ways of using this what to say slicing operation. So this is one such an example. So we and the other one is like slicing multiple and passing to the function which handles a 10, which has a buffer of 10, which can deal with that. So in that case the slicing also will become helpful. Okay. These are kind of little advanced topic, but slicing is able, I guess you should be able to follow it up. So what I'm trying to say is because when if you are using range, the logic here also same. Okay. So the same way we can try. So when we are using a range, we used to have the step value, right? The same thing we can try as well. So let's do that. For example, I'm just taking a value of 20. So 0 to 19 it came. Okay. Now I'm just going to access these elements through slicing. I don't want one from 0th index. I want from 1. And I wanted to stop at mm, index position 16 before. Okay. Before this index position 16. The end value will be 0, 1 to 15. Okay. Here, I'm just going to have the step index. We are having starting index, and step index is there. So how much value you wanted to move. So suppose here I give 2. Okay. What is the result we're going to get? Okay. I'll try printing, not doing this way. So 1 to 15 we got, and here the same values, but for every step we are just moving 2 steps. Okay. The slicing operation will work similar to this, whatever we have seen in the range, where you can use the step value as well. The same way, even the slicing also works. As you can see, 1, 3, 5, 7, 9, 11, 13, 15. So it just skips from 1 to 3, skipping 2, 3 to 5, 5 to 7, likewise. So the slicing operation can be leveraged like this. So there is one more thing I just wanted to give you. Suppose you are not supplying these values, what will happen? For example, if I'm just giving slice without giving the start index, I'm just going to give till the index position. So the value of A I just wanted to you to give. Okay. I'm just wanted a value. Starts. I'm not giving the starting index position. I wanted till the 10th index. Okay. Just before the 10th index. So if I give this way, it will be able to print it. Okay. So what happens here is if you are not giving any value here, it by default it takes the value 0. Okay. I mean the index 0, and from there it went up to the 10th, I mean ninth index, and then we got the result. This way we can access. Similarly, if suppose you wanted to access the values from okay, say for example, I want the value access from 12th index, and I don't know the size of the list until the end. I just wanted to access. In that case, what we can do, this particular starts from 12th index, and automatically it goes through 19 and it ends. Right? We are not passing the end thing. The end index is not passed. So these are like default values it will take. Okay. We can use this behavior to access. I mean, we don't need to give all the values all the time. So it depends on the use case. So sometimes we can take the default values. Suppose you wanted to do a reverse of list. In general, in any programming language, how you do a reversing of list? Here we know the property of list index, right? If you start from zero, the index will start from zero and length minus one. For example, 5 is the length of the list. It will go to the index values range from 0 to 4. There is a negative index. It starts from minus 1, which points to the last element. As you know, if you give minus 1, it will point to the last element of this. Okay. Using this, we are going to print this list in a reverse format. Okay. How we do that? We are going to have this particular syntax Python supports. Okay. If you run this particular slicing, what happens is it takes this particular range, it will completely take the given list, and this index position from minus one, it keeps returning like this. Okay. So the iterator is given here, and for every step, it will go from minus one, minus five, minus two, minus three, minus like this. Okay. That's what happens. If you do this in case of plus one, so what happens is, I mean, it's giving for the namesake. It goes in this direction, positive direction, from left to right. Okay, this is from left to right. You want to traverse. This is from right to left.
Eddie,
Yeah,
can I give some suggestion? Yeah.
yeah,
So this step is there, right? There we are using either positive or negative sign. So positive sign says that you have to go from left to right. If you use negative, it says that you have to traverse from from the reverse order.
yeah,
Negative sign.
yeah. Yeah, okay.
That's all. Yeah.
Yeah. That's what we are trying to say. So in place of this one, suppose if I'm using two, what happens? Let's see. That's a step value, right? We can experiment. We can play around these values. I'll better print both instead of having this way, so that you can understand better. Yeah. Yeah. The same kind of procedures which is followed. So here, since it is negative, we are going from right to left. So for every jump, it starts with 19, then it goes minus 2, it skips 18 and comes to 17, then 17 to 15, and 15 to 13. Likewise, it goes. So when you're giving plus 2, it goes from the left to right, which is like from here to here. So this is the behavior of slicing. Okay. So likewise, there are multiple ways we can use this slicing. So once you started using, you will come up with your own advantages and how we can leverage this. But this is the utmost flexibility given by Python. So if you are accessing the list inside using slicing, this comes very handy compared to any other language. This is the best one of the best feature I have seen. Okay, so the same thing is not possible if you are writing with a single colon syntax. Okay, simple single line syntax. When you go for other languages, the same thing, it comes in a very long code. We have to write minimum 4 to 5 lines or 10 lines of code. When you wanted to write a reverse a string, reverse a list. Okay, since I said reverse a string, that also I'll see. Okay, I'll just give a brief on that, and that will have a long steps. But in Python, it's like a one-liner. You can run it in a single line. Okay, that is one thing. I don't know in the hands-on session we have discussed about list comprehension or not. That also I can explain you now since we have some time. Okay. I will take till 11:30. If you guys don't mind, I will continue. Okay. Say. So what I'm going to do, we have seen the loop, right? For loop. I don't know. I may be jumping here and there, but I just whenever I get something idea, I just wanted to give you. Okay. I don't want to. Uh, okay. For example, I will just come up with my own thing. Okay. Suppose I have a list, range of just going to give 10. Okay. It starts from 1. I can give starting index also. So now the value of A is nothing but 1 to 9. Okay. So now what I wanted is I want a square list. Okay. I want each of these values should be squared. So what I can do, I am creating a new list called S list, square list. Okay. Square list. I want each these values should be squared and stored. In general, what we do, we can create an empty list. We can write a for loop for val in A. Then the square list dot append. We're going to add the values, whatever is getting. The value, what we're going to do, we're going to square that value. Okay, value, the double star is nothing but exponent of squared. Okay. This way you do. Now if at last you print, you'll be getting 1, 4, 9, 16, 25, 36, 49, 64, 81. So this is nothing but the square of all the values. What you get from the A. Okay, I'll just give you this. 1 is squared, 2 is squared, 3 is squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. Okay. This is one way of creating this square list. So for each elements, we are doing this operation. So this particular list operation can be done in a simpler form. That is what we are getting a concept called a list comprehension. Okay. List comprehension is something which is some simple line of for loop we wanted to execute. How we saw Lambda function, right? For writing multiple lines of, I mean, for adding a single line of operation, we have to define a function in a different form. Okay, the regular form. Instead of that, we can go with a simple Lambda expression form. So similar to that, for the list also, instead of having this for loop logic, we can come up with a simple logic. What I can do, I'll make the same logic in a new cell to avoid the confusion. Okay, list comprehension. Okay, take these topics. Okay, copying from here. Just it. So what I'm doing, I'm creating a list of 1 to 10, printing. And this particular list, I'm just going to use a list comprehension to create the square list. What we can do here, the syntax of this is we are using square brackets to make it as a list. Okay, and I'm going to use a for loop for value in A. Instead of using this colon syntax and all these things, whatever value you are reading, I'm just going to put it here. Okay, this particular value. Okay, and what is the operation we are doing exactly? We are just doing multiplied by 2. Okay, when power to 2. So here, this particular flow, this particular selected area, which we call it as a list comprehension. This is one syntax supported by Python. So what it does is, it takes the value of each of this particular iterable, whatever A has stored, it takes that value and it's been passed to this particular, for each value, it does this operation. It's element-based operation. So for each value, it will square it and it will create inside a list. This particular square bracket, what it means is we are going to store this particular operation in a list. So that's why this operation is called as list comprehension. Okay. So once this is done, we can see the end result of square list. Okay. So have you seen the same set of operation what we have done, defining an empty list and then appending the values to that list by using the for loop or everything every time when you are trying to append and all these things. Instead of doing all these particular 3 lines of code, we just replaced with a single line, right? So this is something unique with Python. So this list comprehension will comes in handy whenever we need some simple operation you wanted to execute on the each elements of the list, each element of the iterable. So in that case, what we can do, that particular operation we can put it here, and then we can execute that. I mean, we can write our list comprehension logic, and we can create our list. Okay. So here, there is one more advantage. I mean, there is, suppose you wanted to do some if else logic here, that also can be done here. So for example, if I want the same expression to execute, I don't want it to execute till 9. I wanted to stop this. Okay. For example, I don't want it to do for odd numbers. I wanted to do for even numbers alone. So in that case, we can check if the value is exactly divided by 2. Okay. Just give me a second. Let me check. Even I'm a little confused on this logic. Yeah. Exactly divisible by 2, which means the remainder is 0 means which is an even number, right? So then what happens is, okay. Yeah. So here what we did is we are adding an if condition. Only the value which are exactly divided by which are exactly divisible by 2, only for those values we are going to do this operation. Other values we are simply ignoring it. Okay. That is where, so if you see here, 1, 2, 3, 4, 5, 6, 7, 8, and all values are present. For val in A, if you use, we get only that all the values get squared. When you once you add this if condition, what happens is it is trying to filter the values with respect to this condition. The first thing it will execute is this. Then it will take this val and compare with this if condition. Once this condition is true, then it will come to this expression, it will execute. If suppose this is false, it will continue. This is simply saying like what we did the earlier. So we have done this particular for loop, right? Just give me a minute. Yeah, yeah, somewhere in this line. Yeah, for else is the right. Yeah, yeah, something on this sort. Okay. So where you are reading each element, once this element is not true, then it will continue. If this condition pass, then it will print. Otherwise, it will go for the next. The same logic we have written in the list comprehension. Okay, using this. Okay. So now what happens only for the even numbers, we are squaring and storing, creating a new list. Okay. I'm not sure about the else. Let me try. If the value is, there's some error here. Okay, I guess you don't need to have else. Let me check. Okay, don't, let's not confuse that area. I'll get that off this. Okay, give me a minute. Check that if else can be done.
See, here it's very simple. Directly you have to write the English statement. See, you want square root of, square of each values, right? For every value in a list, if the condition is true. That's what you are writing. See, the English statement directly, if you write right, you will get the list comprehension expression.
Yeah, you are exactly
It's
right.
very simple, very simple. Anything you take, directly you have to write the statement. So your condition is like you want square of each value you want the square of value for each value in the list. If the condition like, if it's an even number, that's what you are writing.
Yeah, exactly, exactly. That's the idea. Yes, sir. So with this, give me a minute. So there are multiple lists also we can use using this list comprehension. That will the problem in that is it will affect the readability. So sometimes Python provide more flexibility to the programmer. If you overuse that, it will affect the readability of the code. Okay. So we have to know when to use. If you go for lambda expression for more complicated expressions, it's better to go with a function which gives more readability. So whenever it's a simple expression, go for it. If it's more complicated, don't go for it. It's better to have a expanded form. So similarly, in the comprehension also, there is a limitation. If you feel it's going beyond multiple lines or something, if you use list comprehension, which is very confusing, don't go for it. And I believe there is some advantage in using list comprehension when you are trying to profile the execution speed of that when it compares to the normal program. Uh, I will explain that in the next session. If possible, I'll try to cover that up. We'll try to execute this particular with normal for loop and with list comprehension, and we'll see the time difference which takes fast and which is slow. That also we'll see. And one more concept I wanted to explain is the generator concept. These are like advanced topics. It's like meant for advanced, but we are covering in this master class. So just to give you a picture, whoever is see, this particular session is even it is helpful for me as well as for you guys, wherein I am refreshing my skills, as well as for you who is learning the language. Instead of just learning what is variable data types and stuffs, getting a hands-on on Python specific power of Python is very good for you to get attracted towards and get started yourself with Python. So that is what I'm trying to do here. I'm trying to influence you to the Python language so that you can explore more on the Python. If you take any other languages to do these kind of stuffs, it needs a long learning phase as well as it needs a long programming steps. So which is reduced. Lots of shorthand handy operations are available readily in Python. Okay. Yeah. Having said that, let's wind up the session. I guess today the information is too much. I
Eddie,
will,
I can give an example of this lambda function.
yeah, yeah. I
You wanted,
will,
right?
shall I stop the screen and then you can, you
Yeah, I
want me
will
to
just
share the
share it.
screen? Yeah,
Yeah, I will share. I will share. Yeah.
yeah. Thanks, Loki. I'll stop my
Mm.
sharing.
So as Eddie explained, I think you people can see my screen, right?
Yeah, we are able to see a screen.
Yeah, yeah. So as Eddie explained, right, lambda is a function which doesn't have any name. It's an anonymous function. So if you see this example, right, I have created an lambda function here. So it doesn't, I have not assigned it to anyone. So if you execute this, it will return something. This is the function object. Okay. So it doesn't have any name. It is just returning an object. So here what we are doing is we are capturing it in some variable. So so this function, right, it doesn't have any name. It is returning something. I am capturing it. And then if I try to run it, right, so this is what he was explaining earlier. Now I will give you an example. So you might want something like square root, square of some number, cube, then to the power of 4 and to the power of 5 something. So if you write a function, right, for each thing you have to write like this: x to the power of 2. You have to define each function for each different operation. So instead of that, using lambda, we can do this. I've created this function. So you can see the result here, right? Eddie, can you explain this, Eddie?
Yeah, yeah, I can.
Yeah.
Yeah. So whatever Loki is trying to do is instead of writing multiple lambda functions, he is making a simple lambda expression and trying to use that. Okay. So one simple change what we can do is we instead of capturing a single value of x in the line 76 cell, right? You can make it as x comma y, and we can make a simple expression of x double star y. Okay, in that case, whatever values you pass for x and power of y, so it will be getting executed. That also can be done. That one improvement I saw. That can be done by a single expression. And this lambda, whenever you are seeing, so the idea behind lambda is whenever we are finding some simple expression, you don't want it to define a separate function, we can do that. And the point here is instead of when there is a need for multiple function you wanted to define, so that particular approach also can be simplified using lambda. That is Loki's view, I feel.
Yeah,
Am I right, Loki? Yeah.
yeah, yeah. So apart from this, one more thing is, I think you might have heard about the sorted function.
Ah, ah.
The day he was explaining, right? What's the
Raj
name?
made me explain.
Raj explained. So this is a list of list element. So it has a different list here.
Yes, yes.
Maybe you can just explain this again. Yeah.
Yeah, yeah. So here what we are saying is actually uh, what he so we are what whenever we saw a list, we just saw simple elements in the list, primitive elements. So what Loki is showing is we have a list of list, which is nothing but a list can have an element as a another list. Okay, so each element, this is like little complicated for you, I mean if you see from the beginner's perspective, but just try to understand. We have multiple sub list inside a list, that's it. So here this list has around three elements, which is like text and two integer values. So what he is trying to do, so whenever, I mean, Python provides an inbuilt function to do the sorting. Okay. So when you do a list, when you're inserting inside a list or anything which you created, so whatever order you insert, that order will be preserved. Okay. Whenever you created a list. So sometimes when you're searching a list, the sorted space is more faster. Okay. Searching or any operations you are doing inside the list, I mean, especially searching and searching is the key thing. So sorted space gives you faster. For example, if you have values 0 to 100 is stored in an array of 100. Okay, the values are scattered. I wanted you to identify the element 55. Where you will look, you will go from 0th index to 100 index. Whenever you see the 55th element, we will see the 55th element is found. But when you go for a sorted space, what we do, we first sort the values. So 0 to 100 we will sort. So we know 55 is something which comes in the middle of the array once it is sorted. So where we will look is, we'll go to the middle of the area and then we'll look. This is how the human brain works. The search algorithm also optimized for sorted space. Okay, let's come to that later. But sorted space is something like when you wanted to sort the list which is already created. So how you do that is, we have algorithms to do that. Python provides a built-in function to do that sorting. So that is nothing but sorted and open close as a function which are passing the array as an object. Okay. Here, as you see, it takes the first element of each sublist and it's sorted. So here the second entry sublist ABM. Okay. Assume that this list has only this text. Okay. ABM, TOY and LBE. So as per this sorting, ABM is the alphabetical sorting. If you take A comes the first. So ABM that comes first. Then comes L. LBE. It is sorted with respect to that. And T. This is what it happens. So in this case, if you see the built-in sorted function takes the first element, whatever it is available, even it is a sub list or any list normal items, it will take that items and then it will sort. But when you go for sorting with, suppose we wanted to sort with the second element, okay, so how do you do that? So in that case, this lambda function will come in handy. Okay, so suppose I wanted to check with this particular second element and I wanted to sort it. What I do, I pass the same array, okay, for the sorted, and the key value with which we are going to sort. That is what the sorted function takes. Okay, this key value can be given as an expression. Okay, so here if you are giving, so it will be sorting. If you're giving this complete sub list, it will by default it will take the first element. But here we wanted to change the element to second. So that is why what we are trying to do here is, we are taking the element of second. So here the index position of the sublist is 1 for 36, and for 55 as well, second index position is 1. So what we are doing is A of 1. What it does is, for every sublist, it will take the key as 36, 55, and 45. Based on this, it will sort. Now the list will be sorted with respect to the second element, which is 36, 45, and 55. The same sorting can be done on the different position of the sublist. Okay, suppose you wanted to do with the third position. So that is what here does with the lambda function, where the key value is assigned to the lambda of a of 2. So this will take the 1012, the index position 2, which is like nothing but 25,000. Okay, as per the original list, it is 50,000, 25,000, and 75,000. If you sort it, 25,000, 50,000, 75,000 should come in order. So that is what happens at the line number 68. So this is the place where lambda plays a key role. Okay. There are several occasions, even you can write your own functions where the input, if you are receiving the input as a iterable container kind of thing. So which element you want to focus in that? That particular value can be passed via lambda expression, which can filter the input accordingly. You don't need to write a logic inside. Instead, the function who is going to use that, the function who is going to call that, the programmer who is going to call that function can be, you leverage this lambda. Okay, that is what this example shows. Okay, so I hope you understand now what happens here. Okay, yeah, he explained the same logic. He explained on outside k is equal to lambda a of 1. So where a is the value, I mean, he has given a list 2, 5, 3. When you give key of 1 l, it will return all the values of, okay, here we don't have
No, no,
one,
only
right? Okay,
no, no, this is A of one is this one.
okay, sorry. A of 1 is 5. Yeah, yeah.
Uh,
So it's for the sub list. He is just giving 5. Yeah, that's it. So these are the places where lambda can be used, and lambda is very powerful if you use it in a proper way, and it become very messy if you are not using it properly. So it's like a double-edged sword. So we have to be careful when to apply, when not to apply. It comes out of experience. The thing is, when the expressions are very small and uh, easy, I mean, when the expressions are very small and you wanted to define a function for it, always prefer lambda over functions. Okay, and the places where you wanted to filter the data, instead of writing a function for this filter, you can use the lambda. So this is one such an application he explained. Okay, and yeah, that's it.
this example you can explain reversing. This is a string, right? So people will understand easily.
Yeah. um yeah, so yeah, let me share my screen. I think this one I will take it up. Yeah, not a big deal. I think, yeah, I'll check. So we have seen the list. So string works in the same way as list. Okay, so for example, I'm just giving you the name. Okay, any popular names you can give. Maybe for example, you can take our Prime Minister's name, Narendra Modi, or else we'll name. Don't create any controversies. Okay, we'll take someone popular name. Okay, Sundar Pichai will take. Okay, Sundar Pichai. Okay, so now the name is something like, okay. Uh, Sundar Pichai is the name. So this is the string. Okay. So string internally works like a list. So that's what we are going to see. So whatever we have seen using slicing and all those steps, we can do the same thing for the string. For example, if I do complete list, this will access the complete thing. Suppose I wanted only start from index 1, 0, 1, 2, 3, 4, 5. Okay. From sixth index, the second name starts. I'm just going to give this way 6 to the end. Okay. So here we are able to access the sliced values. Okay. Similarly, we can access the values like the other way around. Name of till 6, which will give us first name Sundar. Okay. String works in a way where how the list is operated. The only difference between string and list is same way how the tuple we said. So string is also immutable. So mutable and immutable we have seen in the first class. Immutable in the sense once you define you cannot change. Mutable is something like you have a remote, whenever you want you can mute it, you can unmute it. Immutable, it will never be mutable. Okay, you cannot change it. So that's the idea. So string is kind of an immutable thing. Okay. Say for example, here the name value I wanted to replace this Sundar yes with, maybe I wanted to give C. Okay. In place of C, yes, I wanted to replace with C. Okay. So at first it looks like it is possible. When you try to execute it, string object does not support item assignment. So here, what we are trying to do, we are trying to access an element in a, I mean, a position character in a string. Okay, that index position, if you are trying to modify it, it will not allow. So here, what it says is string is immutable. String type is immutable. Okay, in Python. And we saw one interesting feature, right? When wanted to reverse a string. So reverse a list, what we did, we are using this operation called colon colon. If you do one this way, you will get the four. Sorry, I got some syntax error. Sorry, it will come in this way. So if you do here, you will get -1. Okay, you read from here SUNDAR So it complete reverse. So this is similar to the list concept where you do the reversing of string. So in general, if you see any college projects or any college question, interview questions or college, also we discuss about palindrome. What is a palindrome? When a given string is uh, exact copy of the mirror image, even if you take from left to right or right to left, that particular string is called as palindrome. So you wanted to write a logic for palindrome in Python. You don't need to compare each character level. We have a simple operation to do this comparison. Okay. What we can do, suppose I'm just giving a string variable called, for example, I'm defining a value. I'm not getting any. Okay, let's take something like this. Okay, Mayan. This particular string is actually a palindrome. We know that, right? So what we can do, whether this string is a palindrome or not, we can use the if condition logic and string dot. What I'm going to do, string, this particular string in the front side. We don't need to change that. Even if we do this way, it's not going to change anything. For time being, I'm just giving this picture and I'm going to reverse this. If these two are equal, I'm just going to say palindrome is palindrome. Else, I'm going to print. I'm just going to print this as not palindrome. Okay. So this particular kind of check in using Python is very handy. Okay. You don't need to do this expression. We can do this way also. So if we checked in a single line of code where this particular input string is palindrome or not. Suppose we are just adding some other string which the front and reverse is not equal, then it is not palindrome. So to write a palindrome function is kind of a basic thing. When you're a fresher, any interview you go, they will ask you to do that. When they ask you to do it in Python, you write this logic in one line. It's like just like this, you can finish this coding. Okay. So when you go for C or any other language, we have multiple long steps. Okay, that is one. This is one of the advantages I just wanted to point out. I think Lokesh had mentioned the same. So how you do reversing a string? Similarly, whatever we saw is using list, but when it comes to string, it will be useful to estimate whether this right and left to right is same or not. Okay. And one more thing I just wanted to say, there are few functions of string. I think he might have covered during the hands-on session. Raj might have covered. In case he didn't cover, I'm just trying to add those points here as well. Okay. So now the value of st is something like this. Okay. So if some few built-in functions of string, which gives a flexibility of converting the given string in a different format. For example, if suppose I wanted to change this to lower, okay. So this particular string, one minute, which has M as capital and double M, two M's are in the capitals, okay. If I wanted to convert this, I can convert using this simple function. One function is there. And similarly, let me change this particular st value. Let's have this space, okay. Hmm. So we have a function to convert this to uppercase, similar to lower. The opposite of this is upper. This also we can do. And there is something called the title. Okay. So which is used when you want to capitalize only for each word, right? The starting of that particular letter which you want to capitalize, that also we can do. Okay. So there are multiple functions. Whenever you go for this, I mean, particularly this lower or upper can be useful when you're doing a string comparison. Suppose you are entering a login, okay, or your login ID is say something like this, okay. You're given this login ID as Raj, okay. When you are entering, okay, when you are entering, you just give this string value. As you know, enter your, okay, enter your login ID. Okay, you're asking the user to enter and storing this entered ID, and we are trying to compare this value with the existing whatever we have. If it is equal, if login ID is equal to entered ID, then we are going to allow them. Okay, print login successful. Else print invalid username. Okay, this is a real-time scenario where you can see this kind of behaviors. Okay, so in this case, okay, I'm trying to execute this. Okay, so in the top only I'm getting this input where to I'm going to give. So I'm just going to give capital. I'm just going to give Raj like this. It giving like this. So the name is same, but only thing is the case is changed. The username is same. In that case, it says invalid username. So in order to accommodate this kind of changes, suppose you are giving a different way, okay, Raj capital, something like this also is possible. If that way you give, it still says it's an invalid name. So to overcome this particular thing, so because password is something it has to be unique case sensitive. So most of the times if you type the username, any login system, most of the login system will allow irrespective of the type, okay? A case, it's not case sensitive, okay? How they do that internally is they generally come to a point. So maybe they store the values internally as case lowercase or something. So once they entered ID, what they're trying to do, they can do this lowering. Whatever value you enter, you just do this way. If I'm just suppose entering Raj, it still says login successful, which means it converts this to lowercase and then it does that condition check and we are getting this. So these are the cases we encounter once you started live programming where you will be expecting some behavior which is not as expected. When you do the string comparison, the case sensitive is still different. If you say Raj, RAJ, small, and capital RAJ is not equal. That we saw in our hands-on session. But there are some occasions we cannot force the people to enter in the same format. So in that case, as a programmer, our responsibility is to handle that scenario. So here we are lowering this particular case, whatever they have entered, and trying to compare. Even suppose here we are storing in an inconsistent way. Here also, we can change the condition such that both the side we are keeping the case lower so that it will never fail. Okay. Say for example, if I say Raj here, still it pass. Okay. So this way we can ensure whatever the case the user has entered, even by mistake, any case changes also he has done. Our conditional logic will be case insensitive. So these are the things we need to learn from the programming. Okay, whenever you go for. Okay, that's all I guess. I think we have given too much of information today's class. I don't know how many of you able to follow, but definitely the session will be helpful for you guys. Uh, yep. And with this, we'll stop our recording as well. I will just upload this recordings. So please